In this video, we're going to talk about how to factor trinomials when the leading coefficient is not 1. Okay, so the first term in each binomial must have a coefficient and a variable. Okay, the second term in each binomial must have a constant. Okay, so factoring again is the opposite of multiplying polynomials, and when we use the box, we think about the numbers inside the box. The first term of the binomial, the one across the top, or so the first term of each binomial, the one across the top and the one down the side, has the coefficient and a variable, and the second term is just a constant or a number. So for example, ax squared plus bx plus c is equal to a coefficient, so a number and a variable, plus a constant. So we have a number and then a variable and then a constant. And then we'll have a number with a variable and then a constant. And these can either be added or subtracted. All right, the best method to use is strategic guess and check using a product and sum table. No matter what strategy you use, you must always first check for a GCF. All right, example 1. We have 20x squared plus 17x plus 3. Right in descending exponent order, it already is, so that's 20x squared plus 17x plus 3. Check for a GCF. Is there a GCF? No, there's not. So we don't need to factor it. We're going to identify A, B, and C. So A is 20. That's the first coefficient. B is 17. That's the second coefficient. And C is the constant, so that's 3. We list the factors of A. So the factors of 20 are 5 and 4. They are 10 and 2, and 20 and 1. And the factors of C, the factors of 3, are 3 and 1. So we try these factors in different combinations until you find the combination that works to create a middle term. Do not erase any of your grids. They will help you keep track of which combinations you have already tried. So the first combination that we're going to try is already plugged in for you. So I have 2x times 10x gives me 20x squared, and 3 times 1 gives me 3. So notice you put the first term in the top left and your constant in the bottom right. All right. So then we have 3 times 10x, which gives me 30x. 2 times 1 gives me 2x. So altogether, this would give me 20x squared plus 32x plus 3. I needed a 17, not a 32, so that combination didn't work. Right, next combination, we can again try 2x, and this time we can try a plus 1 here, and then we can try the plus 3 down on the left. So we have a 2x here and a 10x here. So again, 2x times 10x gives me 20x squared. 10 times 1 gives me 10x. 2 times 3 gives me 6x. And then plus 3 on the end. So altogether, I have 20x squared plus 16x plus 3. And again, I need that 17, not a 16, so this method doesn't work either. All right, so we're going to try then 5 and 4 for my first factor. So I could try 5x and 4x. And then I'm going to try a plus 1 and a plus 3. So again, we're just trying different combinations until we find the one that works. 5x times 4x is 20x squared. 4x times 1 gives me 4x. 5x times 3 gives me negative 15x. All right, combine these all together. I have 20x squared minus 11x plus 3. Still not what I'm looking for. The middle term's still not right. Cross that one off. All right, we're going to try one more. Let's try the same factors, 5x and 4x. Let's try switching the factors of 3. So we're going to put the plus 3 up top, and we'll put the plus 1 down at the bottom. I'm sorry, this should be a positive 15x up here. So actually, this should be a 19x. I don't know why that says negative there. All right, so here it still doesn't work. 5x times 4x is 20x squared. 3 times 4 gives me 12x. 5 times 1 gives me 5x. And if I combine these all together, I have 20x squared plus 17x plus 3. And so that's the combination that works. So my two factors are found along the top and along the side. 5x plus 3 and 4x plus 1 will be my two factors. I like this method because it's self-checking. You've already got your grid here, so you've already multiplied your factors and you've checked that out. Okay, example number 2, we're going to make sure we write this in descending exponent order. We have 3n squared minus 7n minus 6. So that would be 3n squared minus 7n minus 6. Is there a GCF? No, no GCF in that one. So we don't need to factor anything out. Okay, so we're going to identify A, B, and C. A is 3, B is negative 7, and C is negative 6. So the factors of 3 are 1 and 3, or 3 and 1. And the factors of C, we have a bunch of different pairs to make negative 6. We have negative 3 and 2. We have negative 2 and 3, switch where the negative is. We have a 1 and negative 6, or a negative 1 and positive 6. So again, we're going to try these different factors and different combinations until we find the one that works. Okay, so I'm going to start by trying, we know we need a 3n and a 1n. That's going to be pretty standard. So then I'm going to try first negative 1 and negative 6. So if I put negative 1 and positive 6. So n times negative 1 is going to give me a negative n. 3n times 6 is going to be 18n. 6 times negative 1 gives me negative 6. Notice you can start by putting your first term and your last term down the diagonal. So I have 3n squared plus 17n minus 6. And I need a minus 7n in the middle, not a 17n. So that combination is not going to work. Notice I'm not erasing these because they'll help me keep track of what I've tried and what I haven't. So I have 3n times n. Let's try putting the plus 6 up here and the minus 1 down below. Alright, so this is going to be here 6n and minus 3n. So altogether I have 3n squared, combine those two like terms, plus 3n minus 6. Still looking for a negative 7, not a 3. That combination doesn't work. Alright, let's pick a new one. Let's try 3n plus 2 and n times minus 3. Alright, so I have n times 2, that gives me 2n. 3n times negative 3 gives me negative 9n. So I'll have 3n squared. Negative 9 times plus positive 2 gives me negative 7n. And then I have a minus 6. That's exactly what I'm looking for. So here is my solution. So my final answer for the factors will be 3n plus 2 from across the top, and then n minus 3 from down the side. Okay, example number 3. I have 18y squared plus 32y minus 30. We're right in descending exponent order. It already is, so 18y squared plus 33y minus 30. GCF, no GCF, so I don't have to worry. Oh, sorry, yes, a GCF. I do have a GCF. I can factor out an 18, not an 8, a 3. So that's going to leave me with 6y squared plus 11y minus 10. Alright, so my A is going to be 6, my B is going to be 11, and my C is going to be negative 10. Alright, list the factors of A. So the factors of 6 are going to be 3 and 2, and 6 and 1. Factors of C, which is negative 10, would be negative 5 and 2, or positive 5 and negative 2, negative 10 and 1, or positive 10 and negative 1. So again, we're going to try these factors in different combinations until we find the combination that works. We're going to start by putting A in the first box, top left, and C in the bottom. Alright, so let's test. We just pick any one we want to start with. Let's try 2y and 3y. And let's try 5 and negative 2. Okay, so 5 times 3y gives me 15y. 2y times negative 2 gives me negative 4y. So altogether I would have 6y squared plus 11y minus 10. And I picked the right ones on the first try. Sometimes we get lucky. All right, so there's my solution here. So my final answer would be 2y plus 5 and 3y minus 2. All right, example number 4. I believe this is the last one for today. We have completely factor n plus 2n squared minus 2. So we want to make sure we write this in descending exponent order. So I have 2n squared plus n minus 2. I do want to go back to example 3 for just a second. I forgot that there was a GCF of 3 here. So I want to come down and make sure that I put that GCF of 3 in my final answer. I don't want to lose that GCF when I report my final answer. Very easy mistake to do, as you just saw. Alright, back to number 4. So I have 3n squared plus n minus 2. No GCF this time. My a is 2, my b is 1, and my c is negative 2. So I need to list the factors of a. They're 2 and 1. And if I list the factors of c, be negative 2 and positive 1, or positive 1 and negative 2. It does help to make a list of all your factors before you start, whether you do it in this format or just as a vertical list. Alright, so again, we're going to start with the first term in the top left, 2n squared, and the third term in the bottom right, so negative 2. Alright, let's try 2n minus 1 and n plus 2. So n times negative 1 is negative n. 2n plus 2 gives me 4n. So if I combine my like terms, I have 2n squared plus 3n minus 2. Not what I'm looking for. We'll cross that one out. Alright, I have 2n plus 1. Let's try n minus 2. So we switch the signs. Okay. That's going to give me 2n squared plus n minus 4n and a minus 2. Combine my like terms there. I have 2n squared minus 3n minus 2. Now what I'm looking for, still need a positive n in the middle. So that one's no good. Alright, different combination. Let's try 2n plus 2 up top and n minus 1 on the bottom. So that's going to give me 2n squared here. And that's going to give me 2n, and I have a negative n. Combine your like terms, I have 2n squared plus n minus 2. Okay? Just see really quickly if that's what I'm looking for. I have 2n squared plus n minus 2. Oh, this should be a minus 2n. There we go. Minus 2n minus 2. So that's going to give me a minus n in the middle, not a plus n. Again, not what I'm looking for. All right, across the top. One more time, we have one more combination. We have a 2n minus 2, and we have an n plus 1. So this gives us a 2n squared here and a negative 2 here. Negative 2 times n is negative 2n. 2n times 1 gives me 2n. So altogether, this is going to give me 2n squared. These two will cancel out, minus 2. And that's also not what I wanted. So now we've tried all the combinations. Once you've tried every single combination, it's at that point that you can conclude that your polynomial is prime and cannot be factored. You have to be absolutely certain that you are checking all combinations before you draw that conclusion and that you haven't missed a single one.